Now I'm going to talk about the static balance of two-layer tower. The diagram on the side view is one of the top ball and one of the bottom balls. Its gravity of the ball is mg. The top ball has a gravity mg. In order to balance the tower, the bottom balls will provide a normal force and a friction, and the resultant force of these two forces are a vertical force upwards. It will counteract with the gravity. So here we divide the mg by the numbers of the bottom balls, so we can get the reaction force each bottom ball will get because of the symmetry. Then I'm going to talk about the balanced moment, because both gravity and normal force go through the center of both. So the forces that actually influence the torque that are friction. In order to counteract the friction between the top ball and the bottom ball, the surface will form a force to counteract it. Accordingly, we calculated the value of the force is 1/3 mg cosecond, and its direction is opposite with the friction.
You've gave a picture of the experimental setup, and there is some tape on the tennis ball, and I want to know why there is tape on the tower.
Because first we tape each layer as a group and stacking each layer to a tower. Then we cut the tape between each other, and the reason we do that is because that it can make sure they don't have any gap between each tennis ball, and it will be more symmetry.
So let's move to the second one. You've been calculating the friction coefficient value. So I want to know that, do you think the friction force between the ground and the ball, or the friction force between the balls will affect the tennis ball tower?
Yes. Once the coefficient of friction is bigger, the tower is more stable.
So what is the subject you want to know? Is it the ground, between the ground and the ball, or the two balls?
The most important of the coefficient of friction is the coefficient of friction between ball and balls. Here's my concluding remarks. We use the tape to make sure the balls are. We use the tape. We use the tape to make sure the balls are tightly contacted with each other. The theory we built states that when the fraction of coefficient is bigger than √2, the tower can be stacked, and due to the unequal mass distribution, a slight difference in fraction and coefficient between the balls, our tower can only be stacked to 7 layers. And I also have to say that we also make sure the coefficient friction between the ball and ground, and the value is 1.03. And the reason why the theoretical is unlimited but our tower is limited is because the different size of the ball will form some gap, and the mass between each ball also have some differences, so it will cause the unlimited cause the limit.